Hello everyone, this is Ankesh. I hope you are finding my videos informative and useful for your work. Today we are going to have a small session about a configuration which is available in the in the ESP-IDF ecosystem to enable the pre-built components which we get along with the Espressif toolchain. This session is not going to be like the previous session where we gave approximately 35 minutes for building a program from scratch. But once you are done with the building of your program or your build, there is some configuration which gets created by the build system of Espressif. Now there are certain ways to access those configurations and make amends, add or remove different components which are already provided by the Espressif ecosystem. So before going on to that configuration, you should know that where these components actually reside. So if you have installed the toolchain in your system, in case of Linux, in the home directory itself, you'll find there's a project folder named ESP. There's a folder named ESP. I'll show you in my laptop so that it is easy for you to get hold of it. So I'll go to my home directory, and in my home directory I have a folder called ESP. Now I have multiple installations. I have different variants of Espressif toolchain installed in my system. For this demonstration, because we are following the version 5.5, so I'll go inside the toolchain installation number 5.5 in my laptop. Inside this toolchain, once you go inside the ESP-IDF folder and do ls, here you'll find a folder named components. Now once you go inside this folder, you'll find the drivers which is provided by ESP-IDF or the Espressif ecosystems. Now these drivers are pre-built as per the IPs which are available on this ESP32 SoC. Now we can use these. We actually use these drivers to make ESP32 work, and to some extent we are also allowed to modify these drivers as per our requirements. But let's not go that far for now. We'll start with the example code which we did in our previous session, wherein we built a program with two components, UART-RX and UART-TX. Now with respect to that program, I'll try to show you how exactly you can enable the components which actually reside inside this components folder, but the window to enable or disable it in your build is provided by a different system command, which I'll show you briefly here. So let's go back to our project folder. And it is YouTube demo that we did last time. And let's navigate to this folder. Now here, first I'll have to source my toolchain. So I'll write source, provide the path for my export.sh, and source the idf.py in this directory. Now once we have sourced it, what you have to do is you have to run idf.py menuconfig. People who build custom kernel images for Linux must be aware about this system. So it is not something new or very difficult. It is a pretty straightforward and very common system amongst the programmers. So similar thing is provided here as well. You can simply start this menuconfig, and once you do it, it will run the CMake. and the CMake will build all the components which are associated with your project, and accordingly, by reading out the settings done by you or done by the CMake system that we used for building the program, it lists out the component states. So as you can see, there is something called component config. We'll come to this part later because this is the most important one, but let's start from the first option itself. It says the build type. It has some options which you can select from. So the first option, it says basically the ESP32 has two-stage bootloader. So there are certain settings which you can make for this particular build. So you can select from these two options. They are self-explanatory. They are written in English. You'll be able to understand it. There's nothing. There's no rocket science in it. Similarly, in bootloader config, you can you can make some configurations which are related to the bootloader of ESP32, which gets loaded first in the espressif. For the flashing, I think for the flashing of image, I have to take one session where I have to explain the three partitions which get created inside espressif by default. First is the bootloader partition. Second is your partitions. There's something called, we have to partition the internal flash of ESP32. So the configuration of that partition gets saved in certain location. That comes second in our internal flash, and finally our application code. So this is the first part of that partition, the bootloader area, and there are certain settings which we can do for the bootloader area as they are described here, and it is written in English, so they are self-explanatory. There are certain options which are available there. You can enable, disable RTC watchdog. This is an important configuration. Then serial flash configuration, I think you can select the protocol, or yes, high frequency. These two options are available for your serial flash configuration. Image validation happens by default when we run either when we run ESP tool or when we run idf.py. Once it has finished flashing the image onto the internal flash, it verifies the complete build of the it verifies the complete image that has been flashed onto the memory. So I think these settings are pertaining to that option. So these kind of settings which they are present, which you can carry out inside the menu config. It has some security features as well. You can sign your image so that nobody is able to download it from your chip without providing a proper sign. So you have to first enable it here, then you have to do some programming internally by calling the inbuilt APIs which are present in the component section of ESP-IDF, and then you can enable these options. You can use these options in your build, in your program build. So similarly, this one is very important, the serial flasher that we use. There are multiple modes which are available. So as of now we are using DIO. Queue-out means flash are basically connected in two formats. We have something called QSPI, and we have something the normal SPI, the conventional SPI. So the conventional SPI, where the conventional SPI is used, we use DIO, and if it's QSPI, then we use QIO. So those settings are present here. So in our case, the configuration is DIO by default. Then flash speed 40 megahertz, and flash size is very important depending on the chip that we use. For us, this configuration is actually wrong. The chip that I am using has 4 MB of flash. It doesn't have 2 MB of flash. It has 4 MB of flash, so I should select this as my option. So you'll see what happens once we change the configuration. Similarly, you can select this option. It will automatically detect the flash which is present inside your chip. Then there are certain other options. Before flashing, what is supposed to do, after flashing, what is supposed to do. You can halt the processor once the flashing is done and reset the processor manually when you're ready to run your program. So such kind of settings are there. In partition table, I already told you, you can make custom partition table. In that case, you have to select the first option and provide the file where the partition information is there. Uh, but these things will come in our future videos when we move towards more complex applications. We are just starting up right now. So in the start, we have to first know all the options which are there before we start building our programs. And these compiler options are there. Some of them are very important. Optimization level is very important. One optimization level is very important from our perspective, from the build perspective, and then stack smashing protection is very important. It comes very handy when we are basically instantiating multiple mutexes or semaphores, and we provide different stack size for our tasks in our TOS. So these optimizations help us making a better image, more efficient image of our build. So one by one we can go and find out what each of these options do. Component, inside component config, you'll find every component which is there inside the components folder that we saw earlier, inside the ESP toolchain installation. So you can enable it from here or disable it from here depending on your requirement. So and you can see I actually the system, the way we build the system, you can see UART RX and TX configuration that we made ourselves is also available in the component section. Enable my feature, disable my feature, you can enable that UX and RX from the menu config itself. So that is why I actually insisted everyone that you follow the proper hierarchy of the folders. Otherwise you won't have such properly arranged code and properly arranged build, wherein maneuvering through your complex build becomes easy and smooth, and finding faults and debugging your program also becomes easy. So please follow proper hierarchy of folders the way I am telling you in this video. Let's go, and it is asking me to reject the changes or save it, so I'll say save the changes. So it says configuration saved to the sdkconfig file. Now when we rerun the build system, that means idf.py build, it will rerun the CMake and it will incorporate all the changes that we carried out in our menu config. Now it is building the program. I'll skip this because we have already seen the program is going to get built without any problem. The next thing is we can do same settings from a different place altogether. Here we ran idf.py menu config, but same thing you can carry out from your IDE or your whatever system, whatever text editor you use for your for writing your programs. So in my case I am using Atom. So I'll open Atom in my project directory, the present directory. So you see my entire project is available on the left hand side under the project section, and inside main my main file is there, youtube_demo.c. Inside components I've got my UART-RX and UART-TX, and inside the build I have got the files which get created once we run the idf.build command, idf.py build command. Now here the thing to notice is this file sdkconfig. When we ran the menu config file, idf.py menu config, the changes were actually happening in this file. So when we were selecting something over there, the changes, these macros were getting set. So once we actually changed the flash size of our chip, right? So let's do Control F and write flash. So I'll go down. multiple flash settings were there. So inside serial flasher config, we had set the size. So you see, earlier it was 2 MB by default in our video. Config underscore ESP tool py underscore flash size 2 MB was selected, but we changed it to 4 MB from the menu config. So the same change is reflected here in this SDK config. So instead of opening that idf.py menu config, you can also make the changes to the respective macros present in this SDK config and have the same effect in your build. So it totally depends on you how comfortable you are in operating this system. You are free to manually change the macro settings from the SDK config, or if you want a more interactive GUI and more easy to use system to make the changes in your build and select the components that you want to include in your program build, you can use menu config. Both the ways are absolutely fine. There's no difference in it. So this was all about the menu config and the SDK config of ESP-IDF, and yeah, that's all for this session from my side. I hope this information helps you in your project, and let's see, I hope to see some output coming from the guys watching my videos. Thanks.